Okay, today is very important lecture, and we are getting into more complicated stuff and more interesting stuff. So hopefully, you guys keeping with the material because it will get more and more complicated as we go along. First, let me remind you that Web Design free trial is now over. It was 2 weeks. It was great while it lasted. Now it's over. Make sure to pay for it if you didn't do so yet, because otherwise they will not let you continue with the homework or having access to the book. Remember, this is not free. You need to make sure that you paid for it. If you paid for it, great. If you didn't pay for it, well, do it now. Let's do a little review. Let's see at the things. Could you please turn it on?
It's a diabetic health.
Okay. Let's look at the review. First of all, what is a statement? You guys remember?
It's
Yeah.
group
What is it? It's a sentence which is true or false. It is a type of a sentence which is true or false. Second thing we need to know now is an argument.
the group of statements.
A group of statements.
Claims. It's claims toward the conclusion. Try to prove it.
It's a group of statements, one or more of which claims to support the other one. There's no separate conclusion aside from the group of statements. Conclusion is within the group of statements. Everything is a group of statements. Remember, when you see a passage, it's just a bunch of statements. Then you start working with them, you figure out one of these statements is actually the conclusion. Who knows which one? First one, last one, somewhere within there. Other statements actually claim to provide support for it. There may also be statements which serve no purpose whatsoever. They're not even part of the argument. So then once you figure it all out, you see that there is at least two statements related in this way, that one or more claims to provide support for the other one. And once we establish that, that's when we can finally call this statement premise or premises, and this one conclusion. Now, what kinds of arguments are there? Now we discovered that there is more than one. Yeah.
Inductive and deductive.
Inductive and deductive. And what's the difference?
One is strong.
How strong?
Very strong.
Necessity, based on necessity, right? So if it is based on necessity, this differentially, then we call them deductive. And the other one is based on probability, and that one we call inductive. Now, we actually in this class will pretty much abandon these ones. Yes, that is not something you need for symbolic logic. It is something you'll go further into if you take just a critical thinking class. But since it is symbolic logic, we'll almost exclusively now go on this set. We are interested in necessity, we are interested in deductive arguments, and how do we classify that? That's still going to be an example. We should know deductive arguments as well. So how do we classify deductive? Good and bad, we say valid and invalid. Remember, so they can be valid, they can be invalid. And what does it mean for an argument to be valid? That's probably the most important part.
Sound.
Oh, no. That's the next step. Yeah.
The premises assuming to be true, what you can do.
Assuming premises to be true, what should happen?
That should always be true.
Exactly. Assuming premises to be true, conclusion should always be true. Assuming premises to be true. We don't assume them to be true, anything can happen to the conclusion. But assuming they're true, the valid argument conclusion will always be true. If there's any chance that you have true premises and false conclusion, any chance at all, doesn't have to be actually the case. But there is just the possibility of that, the argument is invalid. And then further we can divide on sound based on whether they are actually true in real life. If they are true in real life, argument not only valid, but also sound. In all other cases, it is unsound because all invalid arguments are unsound. And arguments which are valid but don't have true premises in real life also will be unsound. And similarly with inductive, remember, instead of valid and invalid, what do we call them? Strong and weak. The idea is the same, but it is a little more complicated because we no longer have the certainty. We are not saying that it should always be true. We are saying in a strong argument, human premise is a true conclusion is most likely to be. And if it's weak, less likely. Remember, cutoff there is like 50%. So if it's more than 50% likely, then strong, less than 50% likely, weak. But because of all this vagueness, it's actually sometimes hard to determine, and then we have to evaluate based on common sense, and that, like I said, that whole thing becomes a little bit less interesting to us right now. For symbolic logic, we need to stay on the right side. So this is kind of a big table explaining all this, right? Statements, true or false. Groups of statements could be arguments or not. In order for them to be arguments, we have to have this differential link with one or more claims to support the other one. Then if they are arguments, they can be deductive and inductive. Deductive can be valid and invalid. All invalid ones are unsound, but valid ones can be sound or unsound depending on whether the premises actually are true. Inductive, similarly strong and weak. Weak ones are always uncogent, but strong ones can be cogent or not depending on whether premises are actually true. Whether premises are actually true, epistemological question. We're not going to go there very far, but just mention it now and then. Okay, now let's look at these two, I should say, groups of statements on the left and on the right. What is the difference between these two groups of statements? What is the similarity? Now, in some ways, they obviously are similar. Just to state the obvious, they are both in English language. What else is similar?
Same argument.
Okay, well, before that, even before that, you see that a lot of words are the same, right? Which words are the same? All and are exactly the same in both cases. They all start with all, they all have are. But certain parts are different. And you see that the parts on the right being replaced with just a letter. However, note that the form indeed is the same, meaning that wherever here you have sporting events, here you have A. Wherever here you have engaged in pastimes, you have B, and wherever you have baseball games, here you have C. So it is in that sense consistent, and yes, that would be the form of this argument, and that other stuff which is there instead of A, B, and C is the content of this argument. What kind of syllogism is it, by the way? Categorical syllogism. So that kind of brings us to today's subject, prove invalidity for argument forms. Form and content of an argument. We will need to separate them, and that's one of the challenging concepts to many students, but very important because in order to actually do symbolic logic, you have to work with the form of an argument. So remember that when you talk about inductive arguments, they actually, the strength and weakness always determined by the content. We have to know what we are talking about. For example, if we make an analogy, we have to know what is being compared to what. If it's argument from authority, well, who's making whose authority is it? Who is the person making this original claims? And so on. But remember that with at least some of the deductive arguments, especially with the syllogisms which we saw, that actually is, validity is a question of content, or of the form, sorry. The form of an argument. Because in order to determine whether argument is valid or not, we don't need to know whether they're talking about engage in past tense or what. We need to see whether the form of an argument is a valid form. And that's always the step one before we talk about soundness, which for our purposes, again, is not really that important. So the form of an argument is the internal pattern of reason. If this pattern is good, the argument is valid. If this pattern is not good, then the argument is invalid. Soundness, that's like the second stage. After you determine that the argument is valid, you may ask yourself, does this premise is true in real life? And that usually will also require knowledge of things like history, biology, geography, and all sorts of other subjects. Not to mention the question, what does it even mean for something to be true, which is deeper philosophical question. Okay, so here's an example. Let's say we have this form. We try to investigate it. How do we do that? Well, we did it with the circle, so let's do it again. Whatever's on the right side and the first limit will be our B circle. That will be a circle of B. And the first premise tells us, well, A, RB. So where are we going to then place the circle of A? Inside, right? Because we did that before with other stuff, but A and B is the same thing. And then next premise tells us, well, C are A. So this is our A and all C are A. Where are we going to place the circle of C? Inside. And inside, yes. And now you can see that that is a valid form, because indeed the conclusion tells you that there is simply no way, given these premises, our C is not going to be inside B. Both C are B. That's the conclusion. You can see it beyond any doubt. If you understand the simple visual concepts and simple concepts as any human being of their right mind would do, then you would see that the conclusion follows. So then we know also that anything we put in there, as long as we are consistent, would create a valid argument. If we replace our A, B, and C with sporting events, engage in past tense, and baseball games, as long as we are consistent, let's say we decided that A is sporting events, B is engage in past tense, and C is baseball games. Once we put them in there, that creates a valid argument. And it doesn't even matter what we are talking about, sporting events or anything else. So that's what we call the substitution instance. We took this form and we substituted A, B, and C for something else. Now let's look a little bit at language, because we will need that, especially towards the end of class. Let's say we have this argument, right? This is something you may hear people say. He is a migratory waterfall, so they fly south for the winter. Now, people usually don't think about this when they encounter it in language, but let's try to kind of look deeper into it. First of all, what is wrong here? How do you know that the conclusion follows from the premise? He is a migratory waterfall. Why does it mean they fly south for the winter? What is missing?
Second,
Which is what? Spelling out something which they assume here. What do they assume? Yeah.
migratory waterfowl fly south for the winter.
Exactly. It is assumed, right? But it's not spelled out. Geese are migratory waterfowl. Migratory waterfowl flies south for the winter, so they fly south for the winter. Why do we not spell it out when we speak? Well, if you talk to an intelligent person, they already know this. You don't want to spell everything out like you're talking to an idiot, right? But, most of us immediately understand it, and if you try to actually spell it out like this, people will think that you've been condescending, right? You're explaining things which are obvious. But it still is a knowledge we have to possess to understand this argument. So if we want to be consistent, we have to actually insert it there, spell it out, because otherwise it's not immediately obvious. And then we get this. Is a migratory waterfall. Migratory waterfall flies south for the winter, so they fly south for the winter. Now, a couple of other things you immediately may notice. One of them is, one more thing is missing. How many geese are they talking about? A couple of them? 5 of them? All of them, clearly. They're talking about all geese, all migratory waterfall. So in this case, that would have to be changed. Then migratory waterfall is a category. But how does it relate to geese? What are they both? What they both are? We want to make clear that this is the same category. What are geese? Birds. And migratory waterfowl in this case are also birds. So if you want to be more specific and clear about what you're talking about, you should say that they are birds which fly south for the winter. Also, they is not great to say they, because who's they? Well, we know it is actually geese, but nonetheless, you may want to spell it out, and then you will get something like this. All migratory waterfowl, a bird that flies south for the winter. All geese are migratory waterfowl, therefore all geese are birds which fly south for the winter. See, so that first argument which we saw actually turned into categorical syllogism. It is now syllogism because it has 3 premises, sorry, 3 statements. 2 of them are premises, 1 is the conclusion. All of them start with all. They were not starting with all before. Remember, I told you that the easy way to see the categorical syllogism, it starts with all, no, and some. But now we have to actually make an adjustment to that. That is a standard form categorical syllogism, which starts with all, no, and some. But people, when they speak, don't spell it out. So you can actually turn many arguments into a standard form categorical syllogism, which we'll talk about more next time, by replacing what people say, adding rather to it words all, no, and some, to just make clear what are they talking about when they say geese. If they only talk about some of them, then you should put the word some. If they're talking about all of them, then the word all, and so on. And then we also have to have clear categories here, and we do. We have 3 categories: migratory waterfowl, birds that fly south for the winter, and geese. All of these are clear categories. Now, this argument has form, right? And we can actually extract this form, which we will also be doing more and more, by simply replacing these content words with some sort of letters. For example, we can put A instead of migratory waterfowl and B instead of birds which fly south for the winter. Then the third category we have is geese, and we will put C for that. Once we did that, we see here we will have to put A, right? This is again migratory waterfowl. You see that? And here we have to put C, because it is geese. And here we'll have to put B, because it is birds which fly south for the winter. A, B, and C themselves doesn't matter very much. You can use any letters you want, but you have to be consistent. If you place A, B, and C, you have to make sure that wherever you have migratory waterfowl, for example, it is the same letter. Okay, now that we got this form, what do you think about its validity? Is it valid? Yeah, why? Huh? It follows this very form, which we just draw circles for right here. That's the same one. And since it is the same form, and this form is valid, any argument which has this form, including this one, of course, will be valid. Okay, so this is the idea. And like I said, we will be working with it more, but for now, we will do some interesting exercises to figure it out. Let's look at another form and see whether this form is valid. All A are B, C are B, therefore all A are C. No, because again, if you start drawing circles in this case and try to represent what they are saying, you will start in the same way. All A are B. So yeah, all A are B. That's our first circle. Second part now is called here because you just have to place another circle of C inside B. You don't know exactly where. But it is quite possible that this is the way you do it. And if this is the way you do it, does it tell you that all A are C? No, it doesn't prove it. It's possible that it is the case, it's also possible it's not. Remember that if it's possible that it's not, that it is invalid argument. So that would be an invalid form. This is the way book actually does that. They use B, as you can see, as kind of a background. So they're not putting this big B circle. They just draw it like a background for A's and C's. But it's the same idea. You don't need to actually draw this circle. Because the idea is that this is just the way these categories relate to each other. So if one category B includes both A and C, but there is no reason to believe that A and C are in any way related, then just like here, you cannot assume that circles A and C overlap. They could be not. All you know is that they are inside. Okay, so this is what we're going to do with 1.5 in order to better understand this issue. We will try to prove arguments invalid. Why are we not trying to prove them valid? Because it's more complicated. We'll do it later in class. But proving them invalid can actually be done fairly simply. Remember, any argument, deductive argument which has two premises of false conclusion is invalid. Why is it invalid? By definition of validity. Because definition of validity, valid arguments are the one in which it is impossible to have true premises and false conclusions. So if you have an argument that you know from real life the premises are true and the conclusion is false, what does it tell you about its validity? It's invalid. It has to be invalid. So in order to prove it invalid, we'll do the simple trick. Because sometimes when you talk about things like engage in pastimes and whatnot, it's not as clear. But when you talk about simple categories like cats, animals, dogs, you can make it very clear that premises are indeed true and the conclusion is indeed false. Let's use this last form which we saw right now and replace A here with cats, B here with animals, and C here with dogs. Right? So that's the same point. All A and B, all cats are animals. True? In real life.
Yes.
Yeah. All next premise, all dogs are animals. True?
Yes.
But look at the conclusion now. All cats are dogs. Very hard. So we have the what we call substitution argument here, substitutions instance of this argument, which shows to us very clearly that premises are indeed true and the conclusion false. So does it prove it invalid? Yes, by definition. By definition of validity, it shows that it can't be the case that in this argument which has this form, premises are indeed all true and the conclusion is false. And if it can't be, then the argument is valid, because in a valid argument that we never, ever, ever have. Now, obviously, counterexample method cannot be used with all arguments. You cannot use it to prove argument valid. You can only prove argument valid. So, in other words, you should already kind of suspect that your argument is invalid in order to use this. If you suspect your argument is invalid, you can prove it invalid by simply finding this combination where premises are very clearly true and the conclusion is just as clearly false. Here's another example. You have this argument given to you, all romantic novels are literary pieces, all works of fiction are literary pieces, therefore all romantic novels are works of fiction. Now, first question here is what it's for. What is it for? Yeah, actually, that form here. Right? Because you can see that all romantic novels replace with A, the all A are B, replacing literary pieces with B. So then all already used in B for narrative novels and literary pieces, works of fiction would have to be C, again R, B, because that's literary pieces. And what is then the conclusion?
All ARC.
All ARC. So you see that's this exact form. And since this is the form, what do you know about this fluidity? It's invalid. It is very obvious invalid. But can we prove it invalid? Since we know now that it is invalid, we actually can. And this is the whole idea of 1.5. How do we prove it invalid? We find this obvious combination. They suggest using cats, dogs, mammals, fish, and animals, so that we will very clearly have premises true, conclusion false. So this is the step-by-step process, right? We will do several exercises, and I can tell you right now there will be 2 questions on the exam which require you to do exactly that. First one, you distinguish your premises from the conclusion. Why? Because you will not always be giving argument in this clear form. Like the first premise, the second premise, conclusion. What you will be usually given is just, and you have to figure out one thing. How do you figure out what you're sorry, indicator word. Yes, if you have indicator words for conclusion, fantastic. That immediately tells you what the conclusion is. If you don't, if you have indicator words for premises, then you know what your premise is, whatever left out is your conclusion. Certainly should have some indicator words. Never assume that the conclusion is going to be last. Does conclusion have to be last? No, it can be in the first one, it can be in the middle. But that's always the first step. Then you have to distinguish form words from content words in order for you to be able to actually extract the form. And that is sometimes a little bit tricky, but with a little practice you can do it. So, for example, in categorical syllogisms, the actual form words would be all, are, and sometimes are not. Are not is with some. If you have some, if you have all or no, it will always be just are. But if you have some, this is for the beginning of your statement, right? Sometimes you may have are, and sometimes you may have are. This is your form. Once you distinguish them, whatever is left, you can see here, I did it in different colors, would be your content words, and of course indicator words. You don't worry about the indicator words, you leave them out. They help you identify the conclusion. Once you identify the conclusion and the premises, you are done. Order of premises really doesn't matter, but typically you will see what order makes more sense. Okay. If you have hypothetical syllogism, it's a little bit more complicated. Of course, here we have more words which are content. Our form words would just be if then. Remember that's conditional statement, right? We can have 3 conditional statements for hypothetical, or you can have just 2 of them, and then you will have not. No. So that's again form words. Keep them tagged where they are. If you have disjunctive, it will be either or and then not. You keep this step. Everything else, again, you will need to replace with something else. So let's see a couple of examples. this is categorical syllogism, right? The content words here are semantic nodes, they replace works of fiction. We already saw that you can replace them with any letters you want. In fact, actually, A, B, C are probably not the best. It's better for not to get confused to just use first letters of whatever categories you right? So let's do it with the first one. All R, the full magic those are L, right? Because it's easier. You can use anywhere, but it's easier not to get confused. You already can see that here you will have L as well, and here you will have R, right? So all that you don't have anything here is works of fiction. What letters do you use? W. You use W here, and then here we'll have all R. Right? So this is the form of categorical syllogism. And once you do the practice, it's very easy to do. With hypothetical, we have if, we have then, and we have not. But let's see how we can extract the form. So it says if religious symbolism is incoherent. Religious symbolism is incoherent is a false statement, but we can replace it with just one letter. We can let's do R. Then religious people are irrational. Well, we have a problem. Certainly R as well, but it's a different state. So we can just use I to irrational. Right? Doesn't matter like this. You have to be consistent, but you can't use the same letter to state. Then note that the second line actually says religious people are not irrational. So if I stands for religious people are irrational, what would be religious people are not irrational?
Not I.
Not I, clearly. And similarly with the conclusion, since religious symbolism is incoherent R, religious symbolism is not incoherent is okay, let me repeat it. Since religious symbolism is incoherent is R, religious symbolism is not incoherent is again R. It can't be again R, not R, right? Because you are denying that. You're saying that's not the case. If R is religious symbolism is incoherent, not R is religious symbolism is not incoherent. It's a denial of that origins. Okay, so that's the form here. This is how you extract it from hypothetical syllogisms. This is kind of breaking it up a little bit better. So this is your first premise, right? This is your second premise. This is your conclusion. You just pulled out this R for religious symbolism is incoherent and I for religious people are irrational. And then you see that there is not, so it's been denied, you have to add not. As we will see very shortly in chapter 6, is all this words can be replaced with symbols, and then you will just have a pure form. But for now, we're not doing it. So that's what you will get as a result. This is what you have on the right side of the screen there. Okay, I'm not going to do disjunctive, but the idea is this, right? If you have something and something, you can just write either A or B, and then not B, for example, then the conclusion is it, or the other way around. So let's go through the process of actually proving them above. You're given something like this. That's the first thing you'll be giving. What's the first step? Since some employers are not social climbers and all vice presidents are employees, we may conclude that some vice presidents are not social climbers. What's your first step again? Determine what is your conclusion and what are your premises. Here, conveniently enough, conclusion is last, but it doesn't have to. In this case, it is. Great. Remove, first of all, indicator words, and then all the content words. So this is kind of makes it a little bit easier to see what exactly is what. The word since, remember, is an indicator word for premise of premises. We may conclude that indicator word for conclusion. Okay, so this is kind of, I put it in blue, we are moving. Then you have just some employees are not social climbers, and just connects it with all vice presidents are employees, some vice presidents are not social climbers. This is our argument, but we still have the content. Employees, social climbers, and vice presidents. Replacing them with just the first letters. Right? So we are rewriting it in place with some. What letter should be used for employees? E. E. Are not. Remember, with some you can have are not. Social climbers, yes. All we are E. And the conclusion becomes some we are not S. This is our form. We extracted our form. That's exactly the same thing. E as VE. We can see it in different colors. Now the next step is to replace ESE with some sort of substitution instances so that we could immediately see the argument is involved. What's our goal? Remember what is our goal? Why are we doing that?
See if things are
Huh?
Trying to get involved.
That's a little bad.
like the circle.
No, we're doing something simpler than that. We have proven it invalid. How do we prove it invalid? Huh? Yeah, but what are we doing?
Replacing the word so that we understand it in a better way.
So what would make it invalid? Yeah.
Using the counterexample method?
No, yeah, but what are we doing with counterexample? Okay, but you missed this part. Where to prove it invalid, you should show premises are true and the conclusion is false. So that's our goal. We're trying to find something which will show to us clearly that premises are true and conclusion is false. And that's what we are doing. We are substituting other categories instead of employees and social climbers, so that it would become very clear to us that the argument is invalid. And it will only become clear to us if we see premises definitely are true, conclusion false. So this is what they suggest in the book. I sometimes will get suggestions, sometimes not. That's like actually more difficult exercises when you have to come up with it yourself. But you can. I'm sure that if you think about it a little bit, you can. But here it suggests E animals, S mammals, D dogs. Let's put it in there and see what happens. Some animals are not mammals. Is that true? Yes. All dogs are animals. Is that true? Yes. Therefore, some dogs are not mammals. Is that true? No, clearly false. So you see, we got this combination, and this combination now proves to us that the argument is invalid. If I ask you why, how does it prove it's invalid? What's the answer? By definition of validity. Definition of validity says, if we go back to the definition, you'll see that in a valid argument, it can never be the case if the premises are true and the conclusion false. So by this definition, if you have this case, the argument is invalid.